All right, lesson 5.2. And congruent polygons. All right, a rigid motion maps each part of a figure to a corresponding part of its image. Okay, so we know that. We know that a rigid motion just moves the figure, but the sides and the angles stay the same, right? So now we're going to be more specific. We're moving it and we're finding the corresponding part, or saying what the corresponding parts are, okay? So we're going to identify the corresponding parts. So let's draw. Oops. All right, so this is going to be JKL, and then we're going to have RST, and we're going to label okay. So remember, you have to go by what is on the picture. You cannot go by what it looks like or what you think should be the corresponding part. You have to be very specific. So we can say angle L is congruent to angle R. They both have one arc. Angle J is congruent, to angle T. They both have, I forgot to put on the T, 2 arc marks. And angle K is congruent to angle S. They both have 3 arc marks. We can also say line segment JK is congruent to TS. Now, here's where I need you to start really paying attention to how you write things. J and T are corresponding. So when you write the line segment, J and T have to be in the same spot on the line segment. K and S are corresponding. K and S are in the same spot on the line segment. And the more you do, the better you do this, the easier all of this is going to be, because it's going to you'll just be able to look to see what the corresponding parts are. So KL, K corresponds to S, so S, R, because L and R correspond, and L, J, L and R correspond, so R has to go first, J corresponds to T, okay? All right, so the congruence statement, that's something that you're gonna have to write, definitely for homework, probably for the midterm. So if they say to you, what would the congruence statement be for these 2 figures? We could say triangle LJK is congruent to triangle. Now, here's where it's important. L corresponds to R, so R has to go first. J corresponds to T, K corresponds to S. You have to put in that order to show what parts are corresponding to each other. And the nice thing is, when you have this, you can also immediately find corresponding sides. LJ is going to correspond to RT. JK is going to correspond to TS. LK is going to correspond to RS. So do you see what I'm saying? Super easy if they give you one of them to find the one that it corresponds to. KL would correspond to SR. So you get the drift. All right. In the diagram, DEFG, so we're going to be working with a quadrilateral, is congruent to SPQR. Okay, now we're going to draw them. So it's going to look something like this. This is going to be G, D, E, F. This is 102 degrees, 84 degrees, and 68 degrees. This is 8 feet, and this is 12 feet. Okay, we're going to draw the second one. QRSP, 2x minus 4 and 6y plus x degrees. All right, so this is what you're given, and we have to find the value of x. All right, so find your x. Oh, right here on line segment or side QR. Where's QR? Right here, which means it corresponds to FG. So we can say that actually let's write that. QR is congruent to FG. Okay, so therefore 2x minus 4 is going to be equal to 12 feet. Add 4, 2x equals 16, x equals 8. All right, find the value of y. So here's the y that we're trying to find. It's in angle Q. We know angle Q is congruent to what? Look at the Q, find the same spot in the other segment, so it has to be corresponding to angle F. Okay, they're in the same spot in the congruency statement. All right, angle Q says 6y plus x. Angle F says 68. But we got two variables. Oh, we already know x, so we put 8 in for x. Subtract 8, we get 6y equals 60, y equals 10. Okay, look at the directions. All they wanted us to do was find the value of the two variables. If they wanted us to find the measure of the angle, actually we would already know it. It's 68, right? And then QR, we already know is 12 feet long. Okay. So, one more time. Congruency statements, super important, because then you can see what angles are congruent to each other and what line segments also are corresponding. Okay, properties of triangle congruence. These are going to look very familiar. Reflexive. Triangle ABC is going to be congruent to triangle ABC. Same thing, right? Symmetric. If triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. And transitive, if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then triangle ABC must be congruent to triangle JKL. Okay, so same properties again, and which is nice because it applies to everything we talk about. All right, I want you guys to do page 389, numbers 1 through 3. So turn to that. I'm going to pause it, and I want you guys to do that. All right, you had to identify all pairs of congruent corresponding parts. Okay, this seems tedious, but it's actually a super good thing to practice, because the better you get at this, the easier this chapter is going to be. Angle A congruent to angle C. Angle B congruent to angle D. Angle G congruent to angle E, and angle H congruent to angle F. Okay, AB then is congruent to CD. BG is congruent to DE. GH is congruent to EF, and HA is congruent to FC. All right, number 2, find X. Well, we know that the measure of angle H equals the measure of angle F, so we plug in 4x plus 5 for H, 105 for F, subtract 5, x equals 25. Number 3, write your own congruency statement. So this is what I would highly recommend you doing to look at this type of problem. Write your own congruency statement and then compare the order of the letters. Compare the order of the letters. Okay, so in this case, triangle PTS is congruent to triangle RTQ. Note, please, angle T must be in the same spot in the congruency statement. Doesn't it make sense that that would be congruent to itself, right? So when you write your congruency statement, if you have the same angle, please make sure it's in the same spot. One other note I had on here, P and R are alternate interior angles. S and Q are alternate interior angles as well. All right. They have triangle PTS congruent to triangle RTQ. This is what I do. Oh, that was what we wrote. That works. Okay. Letter B was triangle TSP congruent to triangle TQR. Go to where you have your congruency statement. You got to go TSP, TSP, TQR. Checks. Okay, so you see what I'm doing. Just go in the same order and make sure it lines up. All right, we have triangle SPT congruent to triangle QRT. Same thing. SPT, QRT. That checks. And triangle TPS, congruent to triangle TQR. TPS should be TRQ. So that one does not check. That's the one that's wrong. All right. We are going to look at the third angles theorem. Okay, let's highlight that. Third angles theorem says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Okay, let's draw this. So I think I'll do this line first. All right, so we have A, B, C, D. Okay. And you're shown that those have arcs. You're shown that this is 45 degrees. You're shown that these have arcs and that this is 30 degrees. Okay, so what do we know? We know that angle A is congruent to angle B because of the two marks, right? And we know that angle ADC is congruent to angle BCD. Now, why did I write 3 letters instead of just 1? Okay, if you just say angle C, you don't know which of these two things you're talking about. Is it the whole angle? Is it just this? So when there's more than one thing happening at the vertex, you have to write it with 3 letters. And the middle letter has to be the vertex. So ADC represents that angle right there. BCD represents this angle right here. And notice that I put them in the right corresponding orders as well. Angle A and B correspond to each other. Angle D and C correspond to each other, right? Okay. And so we can say angle ACD, this whole thing right here, is congruent to angle BDC, this whole thing right here. Why? Well, by the third angle theorem, okay? Because if you only look at this triangle, we have a 45, a 30, and then we have the third angle is that whole angle right here, ACD. So if this angle and this angle are congruent, and this angle and this angle were congruent, that means the third angle of BCD has to be congruent to the third angle of ACD. Okay? Now, what else can we say? Angle ACD is going to equal, so angle ACD, this big angle, is going to equal 180 because all of those added up have to add up to 180. So that angle is going to equal 180 minus the other two angles. Okay, so the measure of angle ACD is 105 degrees. The measure of angle ACD has to equal the measure of angle BDC by definition of congruence, right? So therefore, the measure of angle BDC has to equal 105 as well. Okay, we're gonna turn it over just so we have a lot of room because we're gonna do proof. Okay, you are given a picture and it looks like this. And we have a line going down. This is D, A, B, C. All right, and we have some marks on here. Okay, we are trying to prove that triangle ACD is congruent to triangle CAB. Okay, so let's set up our statements and reasons. All right, what were we given in the picture? We know that line segment AD is congruent to CB, line segment CB. We also know that line segment DC is congruent to BA. That was given. And we knew some angles as well, right? Angle ACD. ACD, so the one with two arc marks, is congruent to angle CAB. Okay, now I put the ACD. So I was doing this one and then this one. So when I wrote my other one, I had to go to the other triangle and go the one arc to the two arc so that they were in the same corresponding spot. Okay, also always look ahead, see what you're trying to prove. So this is a good way to start because that's the triangle that we want to prove as well. Okay, so that's why I put them in that order. We also knew that angle CAD, the one arc mark, is congruent to angle, I started with the two arcs, so ACB. Right? Two arc, one arc, and then D. Two arc, one arc, and then B. All right, this was also given. Okay, now this is actually something that I need you guys to remember all the time. And it's something that you can easily forget, but they love to put this in questions, especially proof questions, and it makes your life so much easier if you can just remember it. When they give you two triangles sharing a side, you must remember that that side then is the same, right? Obviously, but that's why people don't remember it, because it's obvious that it's exactly the same, but you have to put it in your proof. So you have to say that side AC is congruent to side CA. And I had to switch the letters because when it's in the what we're trying to prove, the letters are flipped. So that's why we put it like this. Okay, so that is what property? That's the reflexive property because it's the same exact thing. Okay. All right. And then what else can we say? Oh, I'm going to put 3 hash marks on here because that's one of our sides that's now congruent. Okay, well, what do we know? We know the sides are the same, but we also know 2 angles are the same in both triangles. Therefore, we can say that angle D must be congruent to angle B by the third angles theorem. Okay, so now we know this is congruent, and once we knew that, then we can say triangle ACD is congruent to triangle CAB. And our reason for right now is that all corresponding parts are congruent. So we proved that all the sides were congruent and all the angles were congruent. So we could therefore say that the triangles were congruent.